Alright, Lab 2, Exercise 1 and 2. Exercise 1, you're going to identify parts of this little motor assembly. Now, some of these motor assemblies do come with proper magnetic labels on them still, and some don't because, well, they're old and they're school supplies. People are hard on them. But you know that magnets equal and opposite attract. Opposites attract, likes repel. Okay, opposites attract. You want to make sure that what is facing each other in this motor are opposite to each other. So you can simply tuck them together, make sure they are opposite. You do need a north and a south face in this assembly. Click your oscilloscope leads to the input leads on this. You can either use your normal cord or your probe. If you have your probe, set it to 1 times. Do not set it to 10 times. From there, we're going to move over to our oscilloscope. Now, if I can show you this adequately, I can do it from here. So, showing you this adequately here, what you are wanting to do is you are wanting to get a few things set to a certain setting. You want channel 1 volts per division. You want to have set to 1 volt per division. You want to have the time, your seconds per division. You want to have that set to 1 second. That's set to 1 second per division. And you also want to have your trigger up here on the right, your button over here, trigger menu. If you hit trigger menu, the vast majority of your machine should automatically default to that setting. You do want to adjust your trigger setting here to read 400 millivolts. So we're just going to make that get to, oh, it's super sensitive, 400 millivolts. And that is going to allow us to get this set properly. Now, once you have your oscilloscope set, you are going to set it to capture a single sequence waveform, in which case once it's set and it's ready, it will arm itself, and when it says ready at the top of the screen, you're simply going to lift this armature to the top and let it fall once. It should capture an image, and that is what you are going to put onto your lab. Alright, Lab 2, Exercise 3, we are going to set this up where our negative power supply output is going to be clipped to our red lead from our DMM going into our 10 amp terminal. From our common terminal, that is going to be clipped to our red power supply output, essentially creating a closed loop with our amp meter in the middle. Make sure you're on your 0 to 10 amp DC setting on your meter. We are then going to start with our coarse voltage knob to 9, our fine voltage knob to 12, and our current knob to minimum. We're going to turn on our power supply, put it into parallel, and if I can get both of these to cooperate, you will notice that our current on some of these old power supplies is not exactly 100% anymore. Alright, we're going to turn this up. We're going to go by a 1.5 amp reading on our meter, and you'll notice that this is jumping around quite a bit, but if we can get as close to 1.5 as you can, I'm going to call that good enough. But you will also notice that this is not at even 1 yet. It's reading at 0.9. It is a little different than what your meter reading is going to be. So things will move around just a little bit as well. It's old equipment. Alright, Lab 2, Exercise 4, you are going to have your coil that you assembled in Lab 1 and your cradle from Lab 1. If you are not doing this back to back with Lab 1, you need to reassemble your cradle. And a reminder, you want it as close to the magnet as you can without it touching, and it wants to sit as vertically as you can. So if you can get it to sit vertically over top of that magnet without it touching, that is the preferred. You want it fairly well balanced, but again, it does like to start if it is vertical. All right, so now what you're going to do is we are going to grab some whiteout, just some simple whiteout. We are going to take this and we are going to coat one side 1/2. So you are only going to do this on one side of 1/2 of your coil. That's all you're going to do. One side, 1/2. I like to do a coat or two. You will notice there that it is coated only one, if I can get that to focus, one side, 1/2. Now, when that dries, do not set that back in the cradle right away. Give it a second to dry. What we are going to do now is we had previously in our last step set our amperage to read 1.5. Mine has been adjusted. Bring that up to 1.5. If that changes on you, make sure it's sitting at 1.5 the best you can. 1.5 amps on your output. And we are going to take this and then clip this to our cradle, our black lead from our meter, our positive from our power supply. We're going to keep off for a second. Get your coil sitting back in there, and if we simply touch that to there and we give this a little spin, you will notice that it stays spinning. This is going to continue to spin. The whiteout is acting as a commutator. If I take this off, you will see that it stops. And if I put it back on, right now, remember my whiteout is on the bottom, so that would be off. You can also see I have no current flow. But if I give that just a little flick up, if I hold it here with this hand, you can see I have current flow through my meter. And as soon as I drop it, the centrifugal force will carry it through. As the whiteout comes in contact, it has centrifugal force going, which makes it go past it. Now, if I take this off and we observe which way this is going counterclockwise from my right hand side. If we were to take this and reverse our polarity and we start it again, you'll notice it still continues to spin just like it did in the previous. If we disconnect our red this time and we look at this, you will notice it's now going clockwise. Reverse polarity, reverse rotation. Lab 1 and 2, extra information for those of you that are wondering why and how this works a little bit more in depth. So we have a coil here. We're essentially sending DC current through it. In theory class, we learned that when current goes through, we have a magnetic field that is built up around it. And since we are talking electron current flow, if we have current coming from the negative into the positive, our current is going to be going into this coil and up and around in this direction. So if I have current going in this direction through this coil, going through that way in the top, I have current going that way. So if I wrap my hand around that conductor like this, I have current, or a magnetic field, sorry, I have magnetic flux building in this direction around here. Now, this magnet is going to have a certain polarity to it. Polarity 1 on one side, polarity 2 on the bottom side. So this whole plate has one set polarity. If I simply take my power supply and I allow it to go into one side, this coil is going to rotate in one direction. Okay, so let me stabilize that out a little bit from the bouncing. You'll see that that coil has gone clockwise. That means that the field in this coil that I'm generating, simply because there's current flow going through it, and the field in this magnetic plate here are repelling each other in the direction to push that way. Now, if I reverse my polarity and I bring my negative power supply over here, and I put my red power supply on this side, you will notice that it is pushing it in the opposite direction. Now that the current is going the opposite way through this coil, the magnetic field generated by the coil is opposite to what it was when it was in this polarity. And since our rare earth magnet on the bottom of the board did not change its polarity, it's still the same face. If we reverse the polarity in the coil, we reverse the rotational force within the field being generated in the coil. I currently have whiteout on this side of this half of my coil, and if I have this sit in this cradle just like this, I currently have 0 current. My power supply is on. We previously saw that with this magnetic field built on this coil wanted to go clockwise in this cradle. Now, as we're wanting to go clockwise in this cradle, that's in relationship to the magnetic face of this magnet and the magnetic field built on this side of the coil. Now, just with any magnetic field, magnetic fields are going to be opposite. So the magnetic field that's built in this side versus the magnetic field built in this side is going to be opposite, simply because of our left-hand rule with our current flow. Current is going around this. So if it's going this way down here, when it comes up, it's going this way through this one. They're going opposite directions around this coil in reference to our magnet. So with our whiteout on right now, you can currently see that I have no amperage. It's acting like it's a dead spot. Now what's going to happen is if I give this a little bit of a nudge, I'm going to give it centrifugal force nudge, it's going to come around the top. Now as it's coming around, it's going to be coming down, and the whiteout is going to create a dead spot. And as the whiteout comes out of contact, it's going to create current flow. Oh, wants to go the other way. So as that's being open and closed circuit due to the whiteout, that is going to cause this a quick push, and then it's going to be a dead spot traveling on the whiteout, and then a push and a dead spot, and a push and a dead spot.